So, what can continuous fiber 3D printing technology really do for everyday users like us? This time, we want to share a real story about how this technology helped a group of young makers quickly and reliably turn their ideas into reality, right in the middle of an intense robotics competition. Earlier this month, we teamed up with the Phoenix robotics team. Since 2019, they've been competing in the Robot Master, a high-stakes robot battle where top university teams face off in fast-paced mechanical combat. In such intense games, robot reliability is everything. Phoenix ran into a tricky issue. Their infantry robot's reloading mechanism was originally 3D printed with standard PLA. Under constant collisions and stress, the low strength and stiffness of the PLA become a real problem, causing frequent bullet jams and hurting their firepower during the matches. That small part revealed a bigger challenge many innovators face, turning designs into something that actually holds up. So, together with the team, we tried remaking the reloader using continuous carbon fiber 3D printing. The difference was clear right away. The carbon fiber composites gave the part metal-like strength, stiffness, and wear resistance, all while being lighter. The new reloader worked flawlessly even under tough conditions, ending the jam issue for good and keeping their shooter running smoothly. With a desktop 3D printer like our FibreSeeker 3, they could go from design to holding a high-performance carbon fiber part in just a day. That meant the team could complete a full design, print, test, improve cycle in just a single weekend, speeding up development several times over. Plus, 3D printing freed them from traditional manufacturing limits, allowing virtually any complex shape to be made without extra cost or time. The reloader was just the start. Now, Phoenix is applying continuous carbon fiber 3D printing to more critical parts: load-bearing frames, custom transmission components, and lightweight mechanisms. It lets them explore more daring, optimized designs while balancing weight, strength, and development time. This story goes way beyond winning or losing a game. It shows how a technology once reserved for high-end industry is now becoming fast, accessible, and affordable through a desktop machine. Whether it's building robots, drones, custom car parts, or smart hardwares, when creators can easily get strong and lightweight, freely designed parts, the limitation of innovation start to disappear.